or not at least the two that I told you about. So it's loop circuits, and what a loop circuit is it's a circuit that has multiple power sources, and the power sources aren't necessarily grouped together like we did last class. Last class we did two batteries in parallel, two batteries in circuit. Life was in la la land, and everything was perfect and fine and dandy. But unfortunately, that's not how it is normally. Okay, so you can see here, this is an example of a very simple loop circuit where the voltage sources are on opposite ends, and they're neither in parallel nor in series. We don't actually know what they are in, so we need to find another way to solve this. Kirchhoff has two laws. It was the voltage law and the ampere, the current law, and he's going to come up with a third one just for you guys. The one here is called the Kirchhoff loop rule. That's the one that we're going to talk about today. So if I were to show you this circuit, and I would ask you to solve it, you couldn't find me the equivalent resistance, because if you were to break down these two, are we doing it from the perspective of this battery or from this battery? It's not possible. Okay? If I look at the battery on the right, that one there, the current is going in which direction? Yeah. So Genevieve showed me this, and she's right. There is a current going this way, like that. There you go. And what about for this one? The opposite. And then what happens here? Do they both go down? Does this one win over this one? Does this one win over that one? What's going on here? They both go down, but the voltage difference here is stronger than the voltage difference here. So theoretically, there should be some current going actually in this direction, canceling out a little bit of this current. Okay? Well, the point is, it's not easy to calculate, it's not easy to conceptualize, and that's what we're doing today. In a circuit involving one battery, it's simple. When there's more than one power source, however, not as simple. So let's do the method. Now the method requires you to take a leap of faith. So just believe me for just a moment, and we'll see that we'll get to the same answer at the end. So we have our circuit, our simple circuit, two voltage sources, several resistors. And the first step that we need to do is identify our loops. Okay? And in this simple circuit, there are two loops, the left loop and the right loop. Okay? Sometimes they're called meshes. All right, so that's another term for the same thing. All right? But the point is that we have two loops. Okay? If I were to draw a circuit like this, how many loops will there be? Yeah, in this case, there's three loops. And if I were to draw one like this, maybe, how many loops? 4. Yeah, Junior? Not necessarily, but there has to be at least more than one battery. Yeah? So okay, in this case, there would be 4 loops, etc., etc. Okay? Next thing that we need to do, yeah. Come on, Susan. Okay. So Abba's asking me, is this actually 3 loops? Is this one here actually 3 loops? Because there is one loop here, one loop here, one loop here, and one loop here. That might be the 4th loop. The answer is actually yes. There is a 4th loop there, but because that big loop is being consumed by the other 3 small ones, mathematically, you're going to cancel some out, and you're going to be left with the same number of loops. Okay? Good question. Okay. Second thing we need to do, step number 2, first we've identified the loops. Now we have to arbitrarily, this is the part where you have to take a leap of faith, arbitrarily define the direction of the current in each loop. Okay? It just matters that you draw it. All right? You could have chosen the opposite direction of these, and it would still work. It's just going to change the signs in your math. Okay? So now at the end, let's say I decided on a loop in this direction, right? So this is the clockwise direction for loop 1. It's the clockwise direction. If I solved it at the end, and I found out that my current was negative, it means that the current is actually going in the opposite direction. All right, you got the value correctly, you just got the direction incorrectly. Okay? And same thing for any current. If you get a negative current, it's because you've identified the value of a current in the wrong direction. Just switch your thing around and everything is going to work out fine. Okay, perfect. That was our second step. We identified the direction of the loop. So I'm going to just call this loop 1. I'm going to call this loop 2. And the one on loop 1 is going clockwise, and so is loop 2 going clockwise. Okay? Now we have to identify where the volts are being dropped. Okay? So if I'm passing through a battery, all right, most of the time I'm gaining voltage. All right? Sometimes I'll pass through a resistor, and in a resistor, do I gain or lose voltage normally? Lose. Okay, so I gain voltages when there's a battery. I lose voltages when there is a resistor, unless I go backwards. If I'm going against the current, right, that means I'm losing voltage at a battery and gaining voltage at a resistor. Okay? Again, just bear with me for now. When we do an example, you'll see what I mean. And that's exactly what this is saying here. Kirchhoff's loop rule is telling you that within a loop, if you add up all the voltages, it should be equal to 0. All right, so I'm going to write it here. Loop rule. The sum of the voltages in a loop has to be equal to 0 volts. Okay, so I'm just going to go back. That means if I add up the voltage gain from this and the voltage drop from these two should be 0. And then here the same thing. If I add up all the voltages, it should be 0. So that's all we need to do to solve it. Now we just need to establish the equation. So we're going to do this one as an example together. And the first step is to identify how many loops I have. So how many loops do I have here? 2, okay? I'm going to arbitrarily define my direction. I always like it so that my current goes out of the positive end of the battery. So I'm going to go like this because this is the way it goes out of the battery. And the same thing here. So that's going to be the way I do it. If you want to do it the other way around, it's okay. You'll get the same answer as me later, right? And our signs will just be different. I might have a positive and you'll have a negative, or I might have the negative and you might have the positive. Okay, so step 2 complete. I've established an arbitrary direction for my loop. Now we're going to go and set up. Now we know that the loop rule says that the voltages across every single piece in a circuit in one loop should be equal to 0. So I've gained in my first loop. So I'm going to call this loop 1 and loop 2. I'm going to call loop 1. I gained 1.5 volts from the battery, right? And then there's a current that goes in this direction. This loop that I established is a current. So if there's a current here, I'm going to call that current I1, because it's the current that goes through loop 1. And this is going to be I2 for the current that goes through loop 2. All right? So, okay, so what's the voltage drop against R1? Well, I have to subtract it, right? Because I'm losing voltages across the resistor. So I'm losing I1 times R1, which is 4. Okay? So I gained 1.5 volts. I dropped some volts. Oh, look, I'm going to drop some volts again. So minus I1 multiplied by R2, which is 6 ohms. Yeah. So I also dropped some resistance. That's why I'm subtracting it. But look at this. This resistance, this is the tricky part, okay? So I said that I'm going along this side here, but there is a current going in the opposite direction on the other side of the resistance. All right, so I have to add that voltage because it's going in the opposite direction of my current. So this time I'm going to do plus I2 times, well, R2, which is 6 ohms. Okay, so I got a voltage gain, voltage drop, voltage drop, voltage gain. And now I'm back at here, so all that should be equal to 0. And we can clean this up a little bit, right? So I'm going to combine the I1s. So it's going to be negative 10 I1 plus 6 I2 is going to be equal to negative 1.5. Okay? I just cleaned it up a little bit. I combined my I1s. I moved all my constants over to the left, to the right, and all my variables to the left. And now I have one equation with two unknowns. Well, I have another loop now. Let's do it for the second one. So my loop 2, I'm gaining 3 volts. I'm losing the amount of current that's going through R2, right? So I'm losing I2 times that resistance. So minus I2 times 6. But look at that. There was one going in the opposite direction. So I'm adding the resistance there, the current there. So plus I1 times 6. Because it's going in the opposite direction. And now I've done with this resistor. Now I'm coming to this resistor, and I'm only losing voltage here. So it's going to be minus I2 times R3, which is 3 ohms. And that's equal to 0. And again, I'm just going to clean that up. So I'm going to combine my I1s and I2s. I have 6 I1 minus, did I make a mistake? I1, okay. So minus 9 I2 is equal to minus 3. All right. Now I can solve this easily using algebra, 2 equations, 2 unknowns, right? But I could also solve this using a matrix. So minus 10, 6, minus 1.5, and 6, minus 9, and minus 3. You guys know how to solve that? Okay, do it. Solve it. Tell me what my current is. Tell me what I1 is and what I2 is. You can solve it classically, or you can solve it using your matrix. I had 2 loops here, and so I had a 2 by 3 matrix. If I had 3 loops, what would it look like? 3 by 4 matrix. Yeah. Exactly. Got it. Yeah. I1 and I2 with the same resistance. Because that resistance, if you're looking at it from the perspective of loop 1, you have I1 passing through that resistance, you're getting a voltage drop there, but you're also gaining a voltage because there's a current going upwards in that same resistance. And that upwards voltage, the upwards current is coming from this current here. But do we put that in loop 2? Well, it's for both loops. Okay. Yeah. Yeah, so each one's going to have I1 and I2 in it. Okay. Yeah. Anyone solve it? What'd you get? 0.72? Not the number that I So let's see if we wrote down the same thing, huh? Yeah, Nope, c'est pas ça que j'ai eu. Let me see your numbers here. C'est moins 3. All right. So I'm assuming you guys know how to do this. I just want to explain the answer real quick because we're not done yet, really. So what we just found is that in loop 1, the current is 0.58. In loop 2, the current is 0.72. Are both of my answers positive? Both of my answers are positive, which means that I correctly chose the direction of my loops. Okay, if I had a negative number for I1, that means the current's actually going in the opposite direction. Yeah. Not necessarily, but at one point, at one resistor, there can only be one direction. The name of the band. Okay, so let's talk about this resistor here. So okay, before that, we said that my loop 1 has a current of 0.58. So what's the current passing through R1? 0.58. What's the current passing through R2? Not 0.58. So are they going in the same direction or in opposite directions? Opposite direction. So that means that one of them is going to win. Who's going to win? By how much? By 0.14, exactly. So in fact here, the current is going to be upwards 0.14. Okay? So here the current is upwards at 0.14 amps. And here the current is upwards at 0.58. And then what's going to happen here? What's the current right here? It's what? Wake up, guys. What's the current over here? Yes, 0.72. Look at that. If I was Kirchhoff, I'd be happy right now. Because look, my 0.58 and my 0.14 are combining to give me my 0.72. Okay? And so then the current goes in this direction. Yeah. Just when everything fits and falls into place. All right, guys, do this one. This one's a little bit trickier. Here's what this means. I don't know the voltage here. So this is a question mark. The voltage here is a question mark. But I know that my current here is 3.0 amps. Okay? So go ahead, try to solve that. Still trying to solve it? Okay? C'est quoi cette nombre-là? Ok, non, il y a une space somewhere. Ça c'est moins 1.5, ça c'est moins 3. Yes, it's correct. Yeah, but did you listen to what I was saying about the loops? There's something really important here, is that if you have a loop going in this direction and a loop going in this direction, this value is 0.58, this value is 0.72, but at that resistance, there's one current going this way, one current going that way, but you can't have at one point two different currents. So what's going to be the current of that resistor? Well, this one's going in the opposite direction of this one. This one is stronger, it's 0.72, so which one's going to win? That one, and at that one is going to make the current go upwards, and the difference is 0.14. Okay, so at that point, there is a current going upwards for 0.14.
Okay, so there's one current going this way, of that.
Actually, what's happening is the current is going like this, and then here it's going like this, and then here they're adding up.
Okay.
And then they're going back, and then here they're splitting up again.
Oh, and there's okay. So one like that, and one going up, which is the difference between the two.
Exactly.
Okay.
Yeah.
Oh, and I inversed the two by accident.
Okay.
Okay.
I have an idea.
What's your idea? What do you want to show me? This one?
Yeah.
Okay. What's your idea?
I just thought that this side is on series, right? I can assume this and this are series. I can assume that. So I can just say, oh, 3A is the same as here, no? Because that's what I wanted to know if I could do that.
The current really is just for that branch.
Well,
Keep going. Keep working.
what? Or like here.
Yeah. That means the actual current here is 3 amps. Okay, and that's the addition of the two currents. Now you chose your loop this way, but I would counsel against this because the drawing already tells you that the current's going this way. So I would make it go in the other way.
Like E minus 4.5 times I2 plus 3. That's it.
Minus 3 times 2. Right? So.
Ah, ok. Parce que genre, ok, je comprends.
Yeah.
Okay.
I wouldn't say exactly double, but it add up. Yeah.
If this average is the same for both.
Yeah.
Because
No, it's just that's the actual amperage. So remember the last problem? We said that the current from loop 1 and the current from loop 2 are these two numbers, but that doesn't tell us what the actual current there is. It can only be one current there, and that current is 0.14.
So it's 0.14 going that way and that way.
No, it's just 0.14 going upwards, and that's it.
So what's I2 over here?
I2 is the current of this loop, right? But in reality, there's two loops. Yeah. So that would be the current. This 0.14 is after you've taken into consideration both currents. So let's imagine that there's a bunch of water falling downwards and a bunch of water being pushing upwards. Which one's stronger? Well, the one pushing upwards. And so you take the difference of the two, and that's going to be what's pushing upwards. So this one is telling you after you've added up those two, what the current is. So that is the actual current of that spot.
Okay, let's go.
Yeah.
on the second example, we did minus, then we did plus. And this time we just do minus, and we don't.
Well, because look at it. This one is in this loop and this loop at that resistor is going in the same direction.
Okay.
So they're both voltage drops.
Okay.
If you're going back,
Since the other one is on the other.
yeah. So this one I went this direction. This one I went that direction. So it's minus for that one and plus for that one. Yeah. What's that?
Here you know that there's 3 here.
Yeah.
So if you find, are you able to find here, but you just use
Check.
3.
No.
You can't assume that you have 3 amps there because there's a current coming this way and a current coming this way, and they're going to add up to give you that voltage. What? This is for which one? What is this? Where is this equation? Mais c'est pas V1 qui est égal à ça. C'est ça plus ça plus le voltage qui va donner égal à 0.
C'est ça plus?
Comment je fais? Pour mon loop 1, j'ai un plus 9.
Ok, ouais.
J'ai un moins 3 fois I1. Ça, c'est le courant qui passe par le 3. C'est un drop, donc c'est pour ça que c'est un moins. Là, j'ai déjà le courant pour les. C'est déjà marqué, c'est 3. C'est 3.
Ah, ok.
Donc, j'ai pas besoin de mettre I1, I2,
Ah,
n'importe
ok,
quoi.
c'était ça l'affaire.
OK? C'est juste 3 amps. Ça, c'est 3 amps fois le 2. Donc, moins 3 amps fois 2. Ça, c'est égal à 0. Ça, j'ai une équation à 1 inconnue, c'est facile à résoudre. Donc, je peux résoudre pour mon I1. Qu'est-ce qu'il faut que je sache, c'est que j'ai un courant qui passe par là, puis un courant qui passe par là. Et à ce point-là, ça, je le sais parce qu'il y a ces deux flèches. À ce point-là, les deux vont s'additionner puis aller vers le bas.
Ok, ça,
Donc, ça veut
des flèches en
ouais. Donc, ça veut dire que mon I1 et mon I2 doit être égal à 3. Ça, c'est mon équation.
Ok, c'est bon.
Et puis là, je fais mon équation ici à la droite, ici. Donc, j'ai plus V, c'est ça que je vais résoudre. J'ai moins I2 fois 4.5, moins I2 fois 4.5, moins, parce que c'est un autre drop, okay, parce que c'est en même sens que mon courant, moins 2 fois mon 3 ampères, 2 fois 3, c'est égal à 0. Okay. Là, j'ai résolu mon I1 avec cette équation-là, parce qu'il y a un inconnu. Je l'ai mis là-dedans pour trouver mon I2. Donc, je l'ai mis là. Puis après, avec mon I2, je l'ai mis là, puis j'ai trouvé mon voltage.
Ok.
Okay.
Le I1, il est pareil. Le même.
Le I1
Comme
passe par là,
Ouais.
et par là, et par là, mais pas par ici.
Ok, c'est bon.
Okay. All right. Here's your challenge. Not done yet. Conceptually, it's hard. Mathematically, this one's easy. I'm going to start everyone else off, and then I'll come back to this one, okay? Okay, everyone, listen up. Here's what I want you to do. It is now 20 to 3. I'll give you guys the rest of this period. All right? Listen carefully, please. Danielle, you wake up. Wake up. Okay, thank you. So here's what you're going to do. In groups of 2, all right? Are you listening, Andre? In groups of 2, no more and no less. All right. Last class I said groups of 2, and a whole bunch of people did it alone, and I was annoyed because I had so many corrections to make. I don't want corrections to do, so I want you guys to do in groups of 2 problems, for example, 4. And if you're up for it, do this next one too. All right. I might count it as a bonus. All right. So at the minimum, try solving this one, and then the next one as well. We're going to call that an assignment. Due at the end of class in groups of 2. One assignment for every 2 people. Okay? Are we an even number? Yes, we are. No. This we're going to look at how to solve it next class, but you can do it as a maybe a bonus for this one, for this class. But this is your assignment. Everyone needs to do this, okay?
This one we have.
Yeah.